Hello everyone. Today let's solve the problem number 53, maximum subarray, right? So what the question states here, we are given an integer array nums. All we have to do is we have to find the subarray with the largest sum and return it sum. In simple terms, we have to find the contiguous subarray within the numbers that has largest sum and we have to return that particular sum, right? So in constraints they have given here array length up to 10 to the power of this one 5, and the values has to be within minus 10 to the power of 4 to plus 10 to the power of 4, right? So you can clearly see here, and we have to use a linear time, this one great. Basically, let's do one thing. For this, we can just make use of the cadence algorithm. And if you are following my videos, so recently I had explained all the array-based algorithms, right? The first algorithm itself was cadence algorithm. So we'll be making use of the cadence algorithm for this particular problem, right? So we'll be going with the greedy approach along with the cadence algorithm. It will be very simple, basically, right? So you can clearly see here. Example, they have given minus 2, 1. We can just consider the negative numbers as well, right? So it doesn't matter. Minus 2 1, minus 3 4, minus 1 2, 1, minus 5 4. So see here, output that we got here is 6, right? The subarray we have here as 4 minus 1 2 and 1. 4 minus 1 2 and 1, that has the largest sum 6, right? Simple. Let's go with example 2 here. 1, the output that we got here is 1, right? So the subarray 1 has the largest sum 1. We have only one number. Quite obviously, the subarray 1 has the largest sum. See here, this one is having the largest. So you cannot, this is contiguous. We have to consider the contiguous subarray. Again, that part is very important, right? So we cannot just consider minus 2 and we cannot directly go to the 4, right? So minus 2 and 4, we have to consider 4, we have to consider minus 2 1 minus 3 and 4. We have to go with the contiguous subarray. Among that, this one, the maximum sum is this one, the element which consists of the 4. See here, this one is contiguous, 4 minus 1 2 and 1. So this one will lead to basically 3 3 plus 2 nothing but 5 5 plus 1 6. So this we have returned, so we have only one number, will return that one itself 1. So here in this case, this one will be considering whole array elements, this one 5 4 minus 1 7 8, right? So the output will lead to 23, right? So this is fine. They have given us wonderful examples for the sake of understanding, right? So let's consider example 1 for the approach. So this one I'll be considering this one. Just give me a second here, 1 second. So let me go with some color, man. Yeah, this is fine. Let me go with this color. Sorry, let me go with this example basically, right? So here, first thing, as I've said, I'll be going with a greedy, right? So greedy or the cadence algorithm. Just remember this one. We will be going with a greedy or cadence, right? So again, if you don't know the cadence algorithm, very recently I have explained all the array based algorithms, important some 8 algorithms, exactly 8 algorithms I have explained, including Boyer-Moore algorithm, whether it may be cadence algorithm, right? Whether it may be difference array, this one difference sum algorithm, nothing but the prefix sum, right? So prefix sum, these are the things, some of the algorithms that we have considered. 8 very important algorithms, right? So it will be helpful. You can just go through that one, right? So again, I'll not be explaining entire cadence algorithm and then I'll be solving this problem, right? So just go through that if you want to know about the cadence algorithm. Just go with the array based, this one algorithms playlist, and the first algorithm that you'll find there is nothing but the cadence, right? So we'll be going with the greedy or the cadence algorithm for this one to solve this problem, right? So let's consider first example, this itself. So first what we will do, so main idea is to keep the current that is equivalent to the best subarray sum, right? Ending at the current index. So we will be updating the max that is equivalent to the best overall, basically, right? At each element, we will choose whether to start fresh at that particular element or extend the previous subarray. That's what we'll be doing. See here, let's see the walkthrough. So index, nothing but the value uh, equivalent to the current comma max will be considering, right? So for I equals 0, see, I'll just show this one step by step. Let's go step by step. I equals 0, right? So this one index, right? So I equals 0, we have minus 2, right? So we have current equals minus 2. This is C. First one, whatever we consider, this is current, and second one will be going with the max. That's what I said. So for the max, we'll be going with the minus 2. So first this is the first element, right? And at the index 0, this one minus 2 we are considering. So this is fine. For I equals 1, we'll be going with a max of 1 comma minus 2 plus 1, right? So 1 comma minus 2 plus 1, again max will be 1 here in this case, right? This will be max of minus 2 comma 1. So max will be 1 comma current is equivalent to the max of 1. We have to consider the second element 1 comma this one comma minus 2 plus 1, previous element plus current element, right? So 1 comma minus 2 plus 1, so max will be 1 here in this case, right? So next we will be going with the I equals 2. The same steps we will be following till until all the elements are satisfied. Basically, see here, I equals 2 we have, now we have 1, this one I equals this one 2 we have, minus this one, right? Sorry, minus 3 we have, right? So this will be minus 3 comma 1 minus 3, again this will be equal to minus 2 and the max will be 1. Max will be 1, right? Current this time I when I equals 3, when I equals 3, the value is 4 and the current equals max of 4 comma minus 2 plus 4, this will be 4 and max will be quite obviously 4, right? So max will be 4. Now next step we have I equals 4 here, right? So I equals 4 meaning this one index equals 4 and the value is nothing but the minus 1, this one we are considering. For the minus 1 we'll be going with the current equals max of minus 1 comma, again the previous value is 4, 4 comma 4 minus 1, so this one will be minus 1 and minus this one minus 1 and 3, quite obviously max is 3, current will be 3 and the maximum remains 4 itself. We already have got the maximum 4 here, so maximum remains 4, not the 3, right? So this one, sorry, same goes with the other steps as well. We'll carry out the same formula, right? So this one for I equals 5, this one we have 2, the current will be 5 and the max will be 5. So I'll just write here max. I'm just writing the max, not the current element. So we need the max, right? So now we are updating 5 because we will get here current is 2 here. This one we are considering. So we will be going with current equals max of 2 comma 3 plus 2, right? So this will be 2 comma 5, max of 2 comma 5, we will be considering 5, and till now the max is 5 itself. We had previously 4, so we will be updating the value to 5 basically, right? So for I equals 6 we will get max 6, the same formula will be going with. For I equals 7, we will be going with same thing again, so max will remain 6 itself. And for I equals 8, finally let me show this one as it is last. So this one 4, so current will go with a max of this one 4 comma previous one is minus 5, sorry, we'll be going with a 4 comma 1 plus 4, right? So 1 plus 4, so this is negative, so basically we'll be going with a 1 plus 4. So this one will be current will be maximum, current will be 5 and maximum will be basically 6, right? So this one maximum will be 6, it remains 6 itself, right? So as maximum is 6, so we have current equals 5, so we cannot update here in this case, right? So now we will consider 6, the last value that we got here is 6, which is equivalent to the output that they have given in the example 1 within the question. Simple, right? So whatever the output that we got here is equivalent to the output that they have given for the question 1, right? As we are so our approach works absolutely correct. As we are completely familiar with the approach, let's discuss the this one complexities very quickly. So what will be the time complexity here? The time complexity would be big of n. So why the time complexity will be big of n? Because we will be scanning the array exactly once, doing the constant work per element, right? So the time complexity would be big of n. So what will be the space complexity here? The space complexity would be big of n as well. Sorry, big of 1. Sorry, just give me a second here. The space complexity would be big of 1 because we'll be making use of only two integer variables here. One is current and another one is max, as I had showed earlier, right? So in the approach, we considered only two variables, one is current and max. We'll be making use of only two integer variables, current and max. So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 1 and big of 1 respectively, right? So as we are completely familiar with the approach and this one, complexities, let's start writing the code. All right, so first, let's go with the nums, nothing but the guaranteed length that has to be greater than or equal to 1, right? By the problem constraints. Uh, but we have to safeguard, right? So yeah, first let's go one thing. Let's go with the defensive here. No elements uh, has to be equivalent to the 0. If it is a 0, then we have to return 0, right? So here in this case, if nums equals to 0, oh sorry, this one to null, or length of the nums, if it is equal to 0, then we have to return 0. This is fine. The next step is we have to initialize the current as the maximum sum of the subarray that ends at index 0. We know this. If nothing but the current in simple terms, so this one will be nums of 0, and the next step is we will be going with the max along with the current. So this one max, let me go with the nums of 0 as well initially, right? So we have initialized max as the best overall subarray, that is some subarray sum that we found so far. This is fine. Next step is we have to iterate from the index 1 to end, updating current and the max greedily. That's what I showed in the approach step by step for every individual element that we considered, right? Let's iterate from index 1 to end, updating the current and max greedily. We have to articulate the same thing in the form of code. So this one will be int I equals 1, I less than length of the nums. So this one will be length, start length, finally I plus plus. So within the for loop, we have to either start new subarray at the iterated value of the nums, or we have to extend the previous subarray by the iterated value of the nums, nothing but nums of I. So I'll just go with current here. This is equal to math dot max. This is one of the famous problems to solve using the cadence algorithm, or the to solve using the greedy approach basically, right? So this one will be nums of I, comma, this one will be current plus iterated value of the nums. So this is fine, man. Now let's update the global max if the current ending at I is better. So I'll just go with max equals math dot max. So this is fine. Of let me pass max and current. So this is fine. Now let me come out of this one entirely. Now what we'll be doing here, now let's go with the max that holds the largest subarray sum. In simple terms, we have to return the max, right? So this is it for the code. Let me format the code once and let me hit the run button, man, quickly. Clearly, you can clearly see here the sample test cases are getting passed. Let me hit the submit button quickly. So you can clearly see here all the test cases are getting passed, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.